Hey everyone, thank you for tuning in to our webinar today on top-down assembly modeling. My name is Jared Trotter. I'm an applications engineer for GoEngineer out of our Nashville, Tennessee location. And the goal of the webinar for today is to show you what workflow for top-down assembly modeling looks like, how it differs from traditional assembly modeling, and some things to be aware of when you take this approach. So I'll go ahead and come into SOLIDWORKS here and point out the model that we've got. And I'll go ahead and unsuppress a feature here so you can see what's inside of our box for this webinar. You'll see that this is a few components that we've got here, inclusive of a phone and some other accessories here. And these were brought in just with the typical method here of using the insert components option and bringing those in. But what we're going to look at today is using the additional technique of top-down assembly modeling, which lets you model within the context of the assembly. Now, what are some of the reasons that you would want to use top-down assembly modeling as opposed to the traditional method? Well, one reason is that if you have a part that needs to be based on other geometry, so you have other components within your assembly and you want another component to be modeled around it in order to reference that geometry. Another reason could be if you don't want to toggle back and forth between the assembly and your part in order to verify different dimensions. Instead of using that control tab, you just want to do everything in one graphics window. And the other reason is that if you anticipate other parts changing size and then the new part needs to update with it. Those are some reasons why you might use this top-down assembly modeling approach on some of your items. So for this example, what we're going to do is model a phone piece that's custom fit to these other items here, this phone and then these accessories here. It's going to be based also off of this sheet metal box here. So we'll come to the Insert Components option, select the drop down, and select New Part. And you'll notice that the cursor changes. It's got that little green check mark there. This is so that we can click on something in the graphics area, and that will be our starting plane that we'll use to begin sketching on. So we'll just come down here to the bottom of our box here. We'll select the bottom face there. You'll see that in the feature tree is a blue color now, and it says part 1. That's just the default naming convention for any parts that you insert in this manner. And then it also says the name of the assembly after that. So we'll just come normal to this surface here, and what we want to do is convert these edges and then some of the edges of some of the components on the inside here to get that custom fit. Just kind of do an offset operation. So we'll come over here to the side and we'll start selecting some of these edges here, just doing an offset entities operation, making sure that goes in the correct direction there. I'll just grab another one here. And for each of these that I do, I'm going to kind of use the drag method for each of these ends. There's also the trim entities operation that you can use in situations like this. It's really just a matter of preference. I'll come back and switch this one. Now, of course, there's more than one way to get this geometry. I'm using the edges that are pretty much on the plane here. Of course, with offset entities, you can use a plane that's parallel to it, but in this case, I'm just going to use the ones that are on the plane, and I'm also choosing to do the individual lines rather than selecting the face, rather than convert that whole face, because there are some tab and slots there. So do it this way and then just continue to finish up here and drag the endpoint so that we get a complete closed surface, or a closed contour rather. And I'll just use the power trim in this instance. So now we've got the outside edges done, and we just want to do an offset of these two little cylinders here. And now come over and just extrude this to create a simple boss. So we've got the main geometry of our profile here. And we'll just apply a little bit of an appearance just to distinguish it from the other geometry here so that you guys can see it fairly easily. Okay, so with that geometry set, now we want to look at making some modifications here. So, of course, the way that we model this, the phone piece is based on the profile of our cardboard box. So if we change the size of the box, we would expect this new part to update with it. So I'm just going to come over here to the box here. We're going to make a very simple change here. Just change the size of the box so that it's noticeable and we can see the changes propagate. So just change the overall size of the box, change that from 8 to maybe 9.5. And if we go ahead and exit this sketch, see it rebuilds, and now this profile has updated. So no switching back and forth between models. This part is now tied to the profile of our box there. Now, the thing about this part that we've just created is that it's a virtual part. It only exists inside of this assembly. And we've got another part like that as well. This earbud and USB piece that I have over here. I want to open up both of these and show you a little bit of difference that I'm about to make between the two. So I'll come over here and open up the part that we just made here. And go back to our main assembly and open up this other virtual part. So I want to open up the file explorer here that's actually going to show where the other assembly parts are. And if you look here, you'll see the other parts that we made in the assembly, but not the two virtual components here. That's because they exist just inside this assembly. They're not actual part files. So we'll go ahead and make some changes here. I'll go ahead and save this part, and you'll see that it has an external reference there. We'll choose to save the part. Right now it's just in the context of the assembly. We'll go ahead and save it in that same file path here, same as the assembly. And now we see the naming convention changes a little bit because now this is a physical part file. It doesn't list the name of the assembly next to it. But of course it still does have that external reference icon there in the feature tree that you'll see. So if we come over to our main assembly, we want to just come over and save this. And notice what happens when we go and we close out of this assembly. So as we close it out, the only thing that's left is this part. If we go ahead and open or look at the other open documents, our other virtual part is not open because it can only be open when the assembly is open. So that's one thing to keep in mind. If you'll go ahead and save that virtual part external to the assembly as its own part file, then you can access it and continue to make changes whenever you like. But if it is a virtual part that is just inside the assembly also needs to be open. And you'll also notice here in the feature tree that there's a question mark next to the external reference. That's our indication that while the part and its features can be generated, it's still looking for its reference where it's oriented in space, and it needs the assembly in order to be open for that. There's also the option within the assembly to rename the part. So if you just right click on any of these virtual parts here, you'll see the rename part option. And then for any of these parts that we've made in the context of this assembly, maybe we want to see all the references that we've created here and see what dependencies that we have. The way to access that for an individual part is just to right click on it in Tree, choose External References, and you'll see it list all of the reference entities, the type of relationship that we have there. And then if we go to the top level of the assembly, you can right click there, choose the same option, External References, and then it'll list that for all of the different parts that are in this assembly that have those external references, and it will list out to the side there what those references are, whether it be a sketch or whatever type of reference it is there. We have the option to lock those, so we can lock all of our external references that we've made. We can also break them. But rather than use the break option, I'm going to show you another workflow that's a little bit more robust and will actually look a little bit better. If you find that you don't want these external references, like if you don't want to just break a single one of them, but if you want to disconnect all of them and have a part that functions independently, we can just open up this part model and do save as copy. So then this way you'll have a whole nother part that's geometrically the same, but we're just going to kind of change our design intent. So I'll go ahead and give it a unique name. And we can just close that original document there. We're not going to work with that anymore. And I'll go here into the feature tree and edit the sketch. And rather than have all those dependencies, we're going to want to delete these offset operations that we've got there. So I'll just go to display delete relations. I'll see the offsets that I want to kind of break the link from, and so that these dimensions can be on their own. So we'll delete them there. And can go ahead and choose fully defined sketch to go ahead and get dimensions for all of those. So go ahead and regenerate that, and now we see that we don't have any external references there. So now this part file is completely independent, it's saved with its own name, and we still have a copy, our original file there, if we do want that to update. So that's a good clean workflow that you can use in order to preserve the work that you've already done, but then also have a file that's completely independent. So today we've looked at the workflow for creating virtual parts, and then if you decide you want a completely independent part, how to save it externally so that it doesn't have those links anymore. The converse is true as well. You can bring in a part via that normal method, and if you right click on it, there's actually the option to make virtual. So you can turn a normal part into a virtual part. I've never seen a use case for that, but the option is there if you want it. So that's pretty much going to do it for what I have prepared today for this webinar. And I'll go ahead and switch here to a summary of the things that we've talked about today. So the first one is that you want to use top-down assembly modeling for referencing assembly geometry. If you have other components in your assembly that a part is going to be based on, dimension-wise or geometry-wise, you can use it in that way, model inside the context of the assembly. And then if you want to free that part up later, you can make it an externally referenced file by doing a save as copy and then just redefining those relationships there. So then that way you have a copy that is just like a normal SOLIDWORKS part, and then you still preserved the work that you've done when you made it a virtual part. So I'll go ahead and open the floor up to any questions that you guys might have. Okay, so the first question here is, when you make a part virtual, will the original part file stay the same? Yes, the original part file stays the same and the link is just broken. So your virtual file is a separate file that you can work with, and it does not affect the original. Okay, does everything that I'm doing today pertain to SOLIDWORKS 2021, or is it valid in earlier versions? So yes, it does go several versions back. I just chose to do this webinar in 2021 because at the time of this recording, that's the latest version that's out. But yes, these things that we've looked at here today do propagate back to several versions back of SOLIDWORKS. Right. Next question is, once you make a virtual part, can you still modify attachments? Yes. So mates can be edited like normal within the assembly. It gets treated just the same as a normal SOLIDWORKS part does inside the context of the assembly. Okay. Is it better to drive virtual parts from other parts or sketches? So I've seen it most commonly done with other parts, but you can do it with sketches. You could make an argument that because a sketch has less data to resolve, that a sketch is better than another part, but it's definitely most common to use it with parts. Okay, when inserting a new part, what are the advantages of leaving external references and not just breaking them automatically? So it really depends on what you're trying to accomplish. I suppose you would immediately break any external reference if you know that you don't need it to update. You just want the visual advantage of looking at the assembly while you model with one and done dimensions. Also, if you break an external reference, you cannot get rid of that icon in the feature tree there. So if that matters to you, you may want to make sure that the external reference never gets created in the first place when you're modeling. So that icon there next to your part name might be a consideration for how you choose to handle those external references or when you want to break them. How do you make a drawing for a virtual part? Okay, so that would actually be the same way you would for a drawing, and I can just go in here really quickly and show you that process being kind of the same here. So if I go and click on the part within the tree, and just open it up, go to File, and make Drawing from Part. You'll see that our familiar dialog box comes up. And we go over here into our view palette, and of course we've got our typical views. Those can be just dragged right in. So it works the same as it would for a typical SOLIDWORKS part. You can create drawings the exact same way. Okay, next question is, why use layout instead of a sketch from assembly level to control a component? So if your values are two-dimensional, a sketch could work fine. For instance, the one that we use today. But many times virtual components are based off of 3 dimensions. But so if all of your data for external references can be captured in a layout sketch, then that's fine. Right? If creating a virtual part and then saving it as a separate file, does it save the origin location from the assembly? So yes, the origin in that new part is going to be the same as the assembly that it came from. Right? Question, can we control a part dimension from another part? We cannot use global variables since the dimension is at the part level. Okay, yeah, so that's a very interesting case there. So what I would recommend doing is go ahead and creating a global variable in the part, but just to get the syntax for it. So just to get the syntax of what that dimension would look like. So you copy that text and then you insert it into the feature of your virtual part or your other part that you're wanting to be driven by the initial part. So create that global variable just to get that syntax, and then you can copy that and go from there. Right? Is there a rule of thumb for the max number of parts in an assembly when creating and editing parts in the assembly? I've run into cases where it crashes when I have too many while editing parts with the assembly. So not that I've seen, not a hard number on that, but of course the more relationships that you have, more mates and more parts that you have, the longer the assembly is going to take to resolve. Then it becomes a matter of, do you want to go ahead and use large assembly mode or turn down the detail of your parts, something like that. Right? Do virtual parts enlarge the actual mass of the overall assembly, or are there weights only in the assembly? So yes, the masses are included in the calculations of the assembly. So you can just kind of test that out if you want to create a virtual part look at the mass of it, and then delete it, then you can see the differences in the two masses. So it does contribute to the mass of the overall assembly. Okay, we use Pack and Go, but the new assembly is still linked to the original file. Why? So the Pack and Go should be independent. It should create a completely separate file set. So I'd have to take a look at your specific situation to see what's going on there. And we can do a mentoring session if you like and take a look at what's going on there. Can parts be reordered to change priorities? So yes, you can change the parts there in the feature tree. You can drag those if you need to. And last question here, or another question, are there also virtual subassemblies? Yes, there are virtual subassemblies, very much in the same way that you can make virtual parts. As an example, if you have all of your parts in a flat view there in your assembly, you can group them together, make a subassembly that exists just inside the context of that top assembly, but there won't actually be a file that is a subassembly. So yes, virtual subassemblies are a thing. All right. Well, thank you all for attending our webinar today. I hope this information was useful to you and you'll be able to use it. So thanks again and hope everyone has a great day.